Okay, let's do a couple of just simple stoichiometry problems. Let's take a look at the production of nitrous oxide, which is a gas that they use now in racing fuels, etc. If you take nitrogen N2 and you react with oxygen O2 into production of N2O. Okay, there's your simple qualitative statement. Let's make it a quantitative statement by actually balancing the equation. We've got two nitrogen, one oxygen and two oxygen, so we need two oxygen here. Changes the number of oxygen or nitrogen there. So now we've got our balanced chemical equation. Now let's do a simple stoichiometry problem. Let's assume that we're going to start with, let's go 25.4 grams of oxygen, and we want to know how many grams of product we're going to make. We want to know how many grams of nitrous oxide is going to come out of this reaction. Well, you remember the first thing we do, we label where we're going, question mark grams. Now, this is a mass to mass relationship problem. So we start 25.4 grams of O2. Recall that you label everything. This is labeled as grams O2, don't forget the O2. Then we're going to convert grams into moles, knowing that 32.0 grams of O2 is equal to 1 mole of O2. You'll remember it's 32 grams, not 16 like the periodic table says, because it's diatomic. It's one of the 7 diatomic molecules that we need to remember, as is nitrogen. Now we've got the mass, we've converted it into moles of O2 if we do our stoichiometry, or excuse me, if we do our dimensional analysis. Next thing we've got to do is go through our molar ratio. Our molar ratio is 1 mole of O2 will produce 2 mole of N2O. Okay, now the next thing we've got to do, at that step, we are now into moles of N2O. So now we've got to go to grams, since that's our ultimate goal. We know that 1 mole of N2O is equal to N plus O. You recall how we've done this. 2 times 14.0 is equal to 28.0, and 1 times 16.0 is equal to 16.0. Okay, we end up with 44.0 grams per mole. So 44.0 grams of N2O is equal to, okay, we end up, after we've done the math on that, to 3 significant figures. We've got 69.9 grams of N2O. Now that's if we don't worry about the nitrogen, if we only look at the amount of oxygen. Well, let's take a look back and see, well, if I wanted to know how much nitrogen I was using in the same reaction, instead of determining the product as nitrous oxide, let's back up just a little bit. Up to this point, that reaction is or the stoichiometry is exactly the same. Except, instead of going to nitrous oxide, we're going to go over here. So we'll label it question mark grams. Now we know that 1 mole of N2 is equivalent to 2 moles of nitrogen, using a ratio or coefficients in our balanced chemical equation. Now we've got 1 mole of nitrogen is equal to 28 grams of nitrogen. That will give us the number of grams of nitrogen that are required. Okay, that gives us to 3 significant figures, 44.5 grams of nitrogen used. So now we've been able to predict the mass of nitrogen consumed and the amount of nitrous oxide produced. Now I'll remind you, in these type of problems, you'll remember that since I only have one product, the mass of both of the reactants combine together to make the mass of the product. So if I add 25.4 grams of the oxygen to that, I end up with that same 68 or 69.9 grams of product. So there are a number of ways we can do this. That only works if we have a single product. It doesn't work if we have a double product. I'll show you that in the next problem. Okay, in the production of silver chloride, which is an insoluble precipitate, we can take magnesium chloride, which will dissolve, put it with silver nitrate, which we've extracted from a silver ore using nitric acid. It'll produce magnesium nitrate, which is still soluble, so it's just a spectator ion, and silver chloride, which will precipitate out. If I take a given amount of the magnesium chloride and I want to find out how much silver chloride that I'm going to make, let's take 31.3 grams of magnesium chloride, and I want to know how many grams of silver chloride that I'm going to make. The process is the same. We take 31.3 grams MgCl2. We go to the periodic table and we assemble our masses of magnesium chloride. From the periodic table we have 24.3 grams plus 35.5 grams twice, which is 71 grams, for a molar mass of 95.3 grams of MgCl2 per mole of MgCl2. Now, through the ratio of our coefficients, we see it's a 1 mole MgCl2 to 2 moles of silver chloride. We put the 1 mole magnesium chloride in the denominator. We put the 2 moles of silver chloride in the numerator. Now, if I take my next one, I've got to get the mass of silver and the mass of chlorine. The mass of silver is 108 grams per mole. So we take 108 plus 35.5 for a mass of 144 per mole. We do our math, the 140, and I get a mass of 94.3 grams of AgCl as a product. Now, because I have 2 reactants and 2 products, there's no way I can add up the sum of the reactants to get the mass of this product, because I'm also producing this substance in the same container. So I have to watch out for those types of problems.